All right, so we're back with part 2 of our video, and we're going to jump right back in. So we left off talking about phase with using these sine waves. Let's use some real-world examples now. So I'm going to hide all this stuff, and I'm going to pull up an acoustic guitar track, and we'll listen to this for just a second. So it's a nice little acoustic guitar track. What I have here is another track. Once again, it's doubled. And these are the exact same clip starting at the exact same time. So let's play these together now. I'll start with it muted. So here's just the first one by itself. And now when I double it, cool. So it pretty much just sounded like we turned it up, which is essentially what's happening. When these get added together, it gets a little bit louder because they're the exact same mic, the exact same recording, nothing's changed. But what happens if I slide this clip back a little bit? And now we're somewhat out of phase. Imagine we had two different microphones on this acoustic, and one was just like a few feet farther back. One was right up by the sound hole, and the other was just a few feet back. This is the issue we would run into because this second microphone is actually going to hear this acoustic a little bit later, and you might get something that sounds like this. So this is just the first track by itself. And then when we add our delayed track in, kind of sounds nasty, and it can sound very different depending on how far back it's delayed. So let's delay it just a little further back maybe. Maybe a little bit more. Kind of see how bad we can make this sound. Maybe a little less actually. See, as I slide it around, you'll hear it start to sound different. It'll sound kind of funky in weird different ways. And what's actually happening is because we're not dealing with a sine wave here. We're dealing with actual waveforms, which are going to be actual audio signals, vibrations in the air that are going to be very complex. And so you'll see all these little harmonics, these little tiny waveforms that are part of these big waveforms and stuff. And all of those different frequencies are going to start canceling in weird ways. It's called comb filtering. And it's going to start creating these really weird, ugly sounds that we really don't want. And it kind of, depending on how far back it is, certain things will start lining up and being in phase, but other frequencies won't be. And so in this instance, it actually makes a lot more sense just to have the one microphone, quote, on this acoustic. Because when you add the second one in, it starts to sound weird and kind of chorusy. So that's kind of a real world sort of example of how bad phasing can sound. So we're going to get rid of these for now. And we're going to go back up to talk about polarity. We're going to use our sine wave and our 180 degree sine wave that we had. So let's listen to these again. So they're canceling each other out. Let me zoom way in, go back to the beginning so you can see this. All right, so we see we have this 180 degree phase issue. Well, what happens if I just flip this to where all the positives go negative and the negatives go positive? Positives go negative, negatives go positive. Well, we can. It's called a polarity switch, and I actually have a cool little plug-in here ready to go that all I have to do is to flip this little symbol right here. And this is called, this is the symbol for polarity, and this is going to invert the polarity. So it's not gonna like shift anything in time, forward or backwards. We can't do that, especially live, but, well, we can shift it backwards technically, but we're not gonna do that. If you flip this little switch, it's gonna flip the polarity, meaning the positives go negative and the negatives go positive. And I'm actually gonna render this clip really quick so you can see what this polarity switch just did. So when I render that, you'll see that that switch just flipped everything. And I can go back. And so let's listen to it before. Oh, sorry, before. It's canceling it out. And now when I bring this polarity switch in, when I flip it, we're not getting as bad of cancellation anymore because it actually looks like this. So they're not actually in phase. They're technically not in phase because in phase would mean that they start at the exact same time. But we don't have as much phase cancellation. Well, they're more in phase. They're not perfectly in phase because perfectly in phase would be this right here. But we don't have that. We have this. And this sounds a whole lot better than if we took this effect off and had all that cancellation. So in this instance, the polarity switch has kind of saved our butts a little bit. So let's look at a real world example of that. And right here I have, let me make sure I don't have this. Okay, cool. So here's a snare drum. We have a top mic and a bottom mic, which we almost always use. And what you'll see is the snare top mic's actually a little bit closer. So the waveform starts. This is the impact of a snare hit. I'm actually going to make sure these are a little louder. There we go. We're going over the 5-minute mark, sorry. But you'll see that this first mic happens a little earlier because the top snare mic's usually a little closer than the bottom snare mic. So even if I shift this back to line them up, we still have an issue. Because the snare top mic is getting the negative, so this is actually the drum head going down and then coming back up, it's getting this negative polarity at the start. The drum head on the bottom is pointing up at the drum, so its initial impact here is a positive. So we'll actually get some weird cancellation here. And I'll drag this back so we don't have it, I'm not affecting it at all. But this is how it sounds. So it kind of sounds thin. It's not that great. I'm going to loop this snare hit. Make it a little longer. So what happens if we do the same thing we did before and we flip this polarity switch on the snare bottom mic? And I'm actually just going to go ahead and render this. I'm going to, hold on just a second, sorry guys. Okay, I'm going to remove that. So like I said, what happens if we flip this polarity switch? And I'm actually going to go ahead and render this in place so that we can see the waveform. Well, now when we see the waveform, you'll see that this is actually a little bit more in phase. And if I play this, the snare drum sounds a lot fuller. It has a lot more bottom end because our lower frequencies aren't being canceled out as much. So I'll go back. So here's before. Sorry, here's before. And here's after. It sounds a lot better, and that's because our lower frequencies, these big waveforms, aren't canceling each other out as much. And so we're gonna have a lot more bottom end. And so we really can't mess with phase too much besides moving microphones. But sometimes if we have something that's not quite in phase, what you can do is you can flip the polarity switch, which is this little symbol. And this is on like the gain stage of the Yamaha board. So if you click the gain knob down, it'll bring up a menu. And this switch will be in there. So you can flip it back and forth if you have an instrument that has more than one mic, for example, like drums. And if it sounds better, use it. If it sounds worse, don't use it. And that's pretty much it. And I'm going to leave because this is well over 5 minutes. I'm sorry. Thank you guys for watching, and I hope you learned something.